Hi, this is the solution for question 1 of homework 4 from Hw6 Q1. And firstly, we look at the question first. Here, this question gives us the joint density function about x and y, and the first sub question is very easy. We need to calculate the integral of all the space about this function, and the result is that we get the 4 over a, and we make it equal to 1, so we get that a equal to 4. And for the second sub question, x, y, and y uncorrelated, it is very easy. We need to calculate the expectation about xy and expectation about x and y separately. It is very easy. It is just some simple integral calculation, and we get the result. And we find that the coefficient result, it doesn't equal to 0. It doesn't equal, so x, y are not correlated. And as we all know that the correlated is a prerequisite condition about x, y to be independent. So if x, y are not uncorrelated, then x, y are not independent. So the sub question 3 gets solved. And for the sub question 4, it want us to find the joint density function of x squared, x times 2 and y times 2, and it is very easy. At x squared, we need to take use of this method we learned from the lecture. We just said that d equal to x squared and w equal to y squared, and we calculate the derivation, and we get that the result is 4xy. And here we should notice that this function have 4 roots, that x can equal to minus and positive squat c, and y equal to minus and positive squat w. So here we use this function, we should write 4 different roots, and so we just use this formula from the lecture. From slides we get the final result. It is a joint function about z and w. That it is also the joint density function about x squared and y squared. And we also notice that this function is under some conditions, that in other cases this function equal to 0. So here is the final result. And for 5, if we want to prove or disapprove that x squared and y squared are independent or not, it is very easy, because we have their density, joint density function. We need to do a single slide integral calculation about w and z. When we can get the marginal density function. Here is the result, and we notice that the marginal density function multiply together can get the joint joint density function. So x square and y square are independent.